It's looking pretty bloated. Anyway, I welcome you all here. I want to talk to you about soil sampling, and actually there's been a fair bit of discussion about soil sampling already today in a number of presentations. So if you're like me, it gets a little bit confusing sometimes about what to do and how to do it and that sort of thing. And so I'm going to just talk about some of the issues. I guess in terms of regarding to manure application, soil sampling becomes a very important issue. And there are specific guidelines under the AOPA which affect needing to have soil test results, especially in regards to looking at nitrate levels, in regards to salinity levels, and in general in regards to even the soil texture, which can be a site characteristic as well. So why the concern about the need for soil sampling? Obviously, the concern is nutrient buildup, and the nutrients that can build up over time, especially with the heavy applications of manure. And just to give you an example here, over on this side of the wall here, I have two site fields here that we had sampled from a number of years ago. This field site here, north of Edmonton, which we used for the diagnostic field school, was actually a very heavily manured site. Had a lot of poultry manure that had gone over a number of years. It was quite close to the barns, and so naturally it was quite heavy. So nitrate levels up to about 400 parts per million in the top 1.5 feet. Phosphorus levels well over 400 pounds per acre in some areas. Potassium levels very high. Sulfur even to some extent high. Organic matter levels were even fairly well variable. So you got some fairly high levels of nutrients buildup here. And in fact, if you look here very closely, you'll see that in certain areas there seems to be a buildup in one area over the other. Anybody have any ideas why?
Oh, but I was just going to ask you.
This is the gate entrance. That's where they start switching on the manure to start spreading. So
But they also have
that's right. They have different patterns because there are different processes that are going on. So it's not consistent. If you're expecting that nutrient levels will be consistent, they will not be, because of the mobility of the nutrients and how the nutrient levels that are in there, as well as the crop removal rates. So as well as the natural background that could have been there. You compare that to a site that's nearby that we had also sampled. Soil test nitrate levels are quite a bit lower. Phosphorus levels are much lower. Potassium levels, they're high, but not as high as over there. Sulfur levels are very high here. Very high levels of sulfur here that have been accumulated in these locations. pH and organic matter quite variable as well. So there's the issue that you're dealing with. Variability over and relationships to landscapes, past history, and just in terms of types of manure applications that have gone on. I know. It's the wind. I blame it on the wind. We also have here, you've noticed that we've climbed up a fair steep hill here. We also had some soil cores removed from the field site here. If you want to take a look later on, just to look at the variability in terms of soils between upper, lower, and mid-slope positions. You can see the variation that you're dealing with. And the prominent thing that you'll see is that the A horizon, or the organic horizon, tends to increase as you go down the hill. And this is quite typical of a lot of landscapes in Alberta. And in fact, even this one is not as dramatic as some other ones that have been cultivated, where you'll get eroded knolls and those types of things happening up there. And so the erosion will force the upper soil layers to move down to the lower parts of the profile, lower parts of the soil landscape. So you can get this kind of variability due to the landscape, the processes that are occurring there, the types of cultivation activities, and that sort of thing. So how do you sample that? How do you collect a representative sample of that type of a field to represent what kind of variations you may run into? You don't know beforehand what this is going to look like. These were done using a grid sampling. We did a 25 by 25 grid sampling process here. That's something that you can't do. Very costly and very expensive, a time-consuming process. Gives wonderful information, but it's something that's not very practical from a producer point of view. So soil sampling and soil testing has had a fairly substantial history in terms of the types of things they're trying to to measure the variability and trying to get representation. Probably the early kind of concept of soil sampling was what we call the random composite sample. Samples were taken across the field from a number of locations. You bulk it all together, make one sample, and that one sample is supposed to represent that entire field. Obviously, if there's variations across that field, you're going to get some. You're not going to be able to represent that variations very well with one sample. In response to some of the concerns about that, there's been a lot of work in terms of the development of what we call benchmark samples, taking an individual site in the field, an area, so in this case 30 meters by 30 meters, that you would use to typically represent the field in that location and utilize that as a basis for determining that. Now, going back year after year to this one benchmark sample provides a number of advantages and disadvantages. Obviously, if you're going to one area, you're going to have a hard time representing the variations that may occur across the field. But by going back to this one benchmark, you do get an idea of what the temporal variability is, change over time. And especially if you're dealing with something like manure, where you're going to be changing and applying and accumulating over time, that becomes a very important thing, is to go back to the same sampling points year after year to see what the kinds of buildups you are achieving. So that's probably has a strong advantage in that respect. Taking it one step further, we can try and break up the field by according to landscape positions, upper areas versus mid-slope versus maybe lower slope positions that you may sample separately. In this case, this is a random sampling, but you could even take it to the same kind of benchmarking here, where you might have a benchmark here, a benchmark here, and a benchmark here to try and get that kind of spatial representation across the field. Probably that kind of a sampling regime, a landscape benchmarking sampling regime, probably will give you the best advantage in terms of representing the spatial and temporal variability that you might run across in there. Still a fair bit of amount of sampling to do, but at least it can, by going back to them on a routine basis, it allows you to do a very detailed monitoring and watching the sites. As I mentioned before, grid sampling is what we did with those, and that's a very intensive sampling going across the fields. You're still sampling a number of cores within, say, a grid point there, and utilizing software like Surfer or some of the other types of software around, you can generate maps to represent the say, nutrient levels that way. Very expensive. You're now talking about maybe 100 samples instead of 3 samples, or 1 sample, or 1 sample here. So the number of samples is quite a bit. So if you're rich and have lots of money and you got a good deal with the lab, hey, might be worthwhile. Might be worthwhile to do it once, or at least I can definitely consider the landscape. Now, in terms of samples and sample handling and processes, Dan Heaney talked a little bit this afternoon about sampling and the needs to preserving the integrity of the sample once you've collected it in the field. You've gone all through this effort of collecting the sample, and you threw it in the back of your vehicle and left it there for a week. That sample doesn't represent the field anymore. It's changed. You've incubated it. You've provided an opportunity for it to change over time. Integrity has been lost, and so you've got to try and preserve that integrity, or else get the sample to the lab immediately so that you can take full advantage of it. So that's probably, in terms of sampling protocol, that is probably one of the biggest mistakes that happens, is that the samples aren't handled properly once you've collected them, and there's a need to do that. Just out of curiosity, how many here have had experience going out to the field collecting soil samples? See? And so am I making sense when I'm telling you all of this, or or have you got some different experiences than me? No? Pretty basic, isn't it? In terms of some of the soil sampling equipment, obviously if we're wanting to get down to something like 60 centimeters, you're going to need some heavy-duty equipment to get down to that level. Equipment, machinery, truck-mounted samplers is what you're going to need. You're going to maybe hire someone to do that. For some of the surface sampling, there are a number of sampling tools that are available. Some have better advantages than others. Some simple samplers like this step-on sampler. Very easy to step in and take a sample and pull it out. Other core type samples, much longer barrels, able to go much deeper. Still, when you're dealing with things like rocks and that sort of thing, you still may run into difficulties with that. We have samplers called step-on samplers to help bring them to push them in much deeper. And we've got some other samplers that are not as appropriate. Anybody know what this is? Dutch auger. For nutrient sampling, it's probably not recommended. The reason? You get too much mixing. You want to preserve the difference in the depths and the horizons, the profile. So this is not going to be a good idea to use, and nor is this. This type of sampler just will not work when you get past 6 inches. So that's going to be my conclusion. I'm going to tell you about soil sampling, and if there's any questions.